Yeah, so I was excited to interview Juan. Unfortunately, he couldn't come in person, so it's like turned out to be quite a long conversation of 2 hours. But we'll just do like 20 minutes of like DeSci highlights, and then put up the link if you want to see the whole interview. But for context, basically, Juan kind of like created IPFS and Filecoin and Protocol Labs in I think 2013. Really motivated actually by science, and is insanely deeply involved in scientific efforts, like doing fast grants in longevity, like funding over 200 projects with impetus grants with like 30 million donation, and advancing brain-computer interfaces, advancing kind of like the state of the art in AI chips. Like he's quite prolific, engaged in the sciences quite broadly. Also coming up with new mechanisms within protocol labs, like for example, retroactive rewards and impact certificates with a project called HyperCerts, and like trying out a lot of novel incentive mechanisms also within protocol labs. So with further ado, just kind of like the 20-minute highlights and the link at the end to the full conversation. Juan is the architect behind Protocol Labs, IPFS, Filecoin, and many other groundbreaking initiatives. And in my opinion, one of the most inspiring creators and intellectuals in technology and science, broadly building and advancing some of the most important technologies and scientific efforts. I'm super excited to chat to you today.
First off, thank you so much for the super kind intro. I'm super excited to be here, and also very excited to work with you and many other people in the community on a ton of these problems. So very excited to talk about them.
Amazing. I'm curious kind of like on this thread, like there's of course like a lot of also problems. So like more like with the current ecosystem probably of like science, but also more broadly things like that I think the progress studies movement kind of like is framing as just like holding back general economic, scientific, technological progress. And I think which go probably even beyond science, like as you mentioned, like engineering, kind of like technology quite broadly, right? Like what do you think are some of the underlying reasons that like hold back progress? Like, and like how do you think we could potentially fix them, like with decentralized science, but also more broadly?
Yeah, so I think there's a lot of different kinds of problems, but my sense of the biggest problem around is that there's this massive bottleneck in science translation. So I used to think that the biggest problem was things like science funding. I used to kind of read a lot of papers and do a lot of science myself and so on. And I always thought like, oh, there's just so much to discover and we need just a lot more funding in kind of discovering more. And it's actually incorrect. It turns out that that although we certainly need more funding and more studies and so on to kind of be able to discover more, the big problem is not there. It's actually a little bit downstream of that. It's in when you're trying to translate the concepts that you have now thought about and put into a paper and discovered, and how you translate those into something that can benefit some other process somewhere else and get connected to some other part of the economy. And the reason why that's the biggest problem is that what's preventing scientific discoveries from actually impacting the world is that they, at the end of the day, have to translate in some way to some application, right? So learning something new for the species is amazing and fantastic, and it's great to be able to discover more about the universe. And like, there's something extremely beautiful about and wonderful about being able to know more of that knowledge. But the great value comes when the entire species is able to leverage that new knowledge to do something better and to do something greater than we could before. Things like discovering that there were really small microorganisms in our water is what led to germ theory. And germ theory was extremely useful and valuable and great to learn about because it enabled us to clean up all of our water, to know that it's important to wash our hands, to have this massive hygiene revolution that enabled just billions of people around the world to survive what otherwise would have been really unnecessary deaths to kind of like lack of knowledge. And so that, so to me, kind of like the big bottleneck is in how we take our science and our discoveries and we translate them into concrete projects and artifacts that could eventually be put into some other set of things like products or systems and so on. So this is kind of known as a science translation problem. And that I think is the biggest issue in the entire system. There's of course other kind of broader things that we could talk about, things like problems in credit, problems in replication, problems in funding, problems in kind of just the rate of innovation and discovery and so on. But in my sense, like a lot of those things are downstream of this bigger problem that even though we are doing an enormous amount of science, most of it is just piling up and kind of being wasted. It's not actually translating into successes downstream. And it also ends up drying funding because agencies and philanthropists and many other and technology companies and many other groups that would be funding early research or fundamental research end up not seeing the results and the impact, and so aren't able to continue funding it. And so I think for embedded in the kind of 21st century where we are, and specifically in 2023, we have a global macroeconomic system that requires these strong feedback loops between some activity that you want to do and harnessing value, creating and harnessing value to be able to feed it back into itself. And I think like that's, if we can figure out some new ways of funding the area, incentivizing and funding the area downstream of science, of like raw scientific discovery, it's still science. It's still kind of like researchers are required to do this kind of work. It's extremely hard discovery work, but it's not as maybe like highly valued by the scientific community in terms of kind of the big breakthrough discoveries. But it is what I think is the most important work to be done, which is how do we take the core fundamental things that we've discovered and figure out how to use them in the whole world.
For the audience of builders in decentralized science, like what would be some of your like advice or like things you would like to see built, or like some of maybe small prototypes that people can start hacking on that you would be excited to see, also maybe integrating with some of the other ideas you mentioned, which I think is like one of the powers, of course, of decentralized science, kind of this modularity. So maybe you have some last words for the DeSci audience.
Yeah, totally. So maybe I'll give two categories of it. One, I'll maybe mention a bunch of like really interesting things that people are doing right now and experimenting with. And then second, I'll like point to a set of like kind of sources for inspiration. So on the first part, I think things like making credit attribution an on-chain primitive would be pretty valuable. This is one of the things that we sort of discovered through the source credit project a while back. Like just creating like credit attributions on-chain will be pretty valuable. I think the second is better funding mechanisms for R&D will be very helpful, and these can come in many flavors. So one that we haven't touched on very much so far in the conversation, but one that I'm just so deeply excited about is hypercerts. Hypercerts are an on-chain version of impact certificates, and also made by David, by the way. Hypercerts gives you a tool chain. A lot of us working on the hypercerts project are super excited about like the tools that you can build around hypercerts. They're extremely composable. You can do things like proactive funding. You can do things like retroactive funding. They just enable you to kind of split a credit distribution on chain, kind of like what I was describing before, but it gives you the ability to think about all the claims in credit space and then make that a transferable asset. So it's not just the credit attribution on chain that you can like route money to. It's also a transferable asset potentially. And that means that you can start doing things like sending money back in time. I'll kind of like leave that as an interesting, instead of explaining it here, I'll leave that as an interesting thing to talk about in the future or find it elsewhere. I think things like, we sort of discovered a mechanism that's pretty interesting called, we currently call it impact evaluators, but this name probably should change. It's kind of a generalization of block rewards. But if you can kind of route block rewards to a pool of actors that is all kind of trying to maximize some KPI, you can make some very simple on-chain structures to change a lot of things very quickly. So I think those kinds of things are like pretty exciting. I think things like radical drips are pretty cool. So there's another way of like doing like small composable value flows. I think things like I'm pretty excited about a thing I'm starting to call like network capital or impact capital, where it's like you can create investment funds in early R&D work or like other kinds of impact and make small groups, small funds that kind of mirror the venture capital structure. So venture capital has all kinds of funds at different scales, small seed funds to like individual angels to like larger VC funds to like fund of funds and pension funds and so on. If you can kind of like create that same kind of network oriented structure, but for impact capital, that could be extremely valuable. So this might mean like one of the key things to solve there is how do you have a notion of carry in impact ROI? How do you have a structure where all the people working on impact funding end up benefiting from the work that they're doing? This is one of the classic incentive problems in grant making, like the fact that grant makers don't actually get some of the impact or make profit. It just means that grant making is just like fraught as a field. And so I think if you can create that kind of structure, it could lead to a much better kind of like early scale R&D type of pipeline. And I think hyperstores can be used as the kind of like equivalent way of like propagating. Hyperstores might give you the way of doing carry there. I think there's a lot of other kind of so that's kind of like funding mechanisms wise. Maybe I'll mention people should be experimenting with like open access tools. So being able to kind of make all the artifacts in science easily linkable and routable. So papers, figures, data, the individual scientists, and so on. Like build like there's a bunch of like centralized databases that have like done parts of this. Think of like Google Scholar or Mendeley and other things like that. Being able to like make this an internet native thing that's internet routable will be way better. So being able to have like something closer to Wikipedia for this sort of set of artifacts, that will give us a lot of ability to then create a bunch of other tools around those artifacts, right? So think of kind of like making the social network of science in a sense. I think that could be super valuable. I think also mechanisms for peer review. So funding peer review at scale, I think is the way that we get rid of like the bad journals. So we don't yet have open access because there's these like extremely terrible leeches in the scientific process that are kind of like holding back all the papers and just kind of they kind of like they used to say that it was distribution costs and we eliminated that with the internet. They used to say it's kind of like formatting and so on, but we have it's not really the case because scientists do all of that work themselves. Now the kind of like last argument is peer review, which is kind of volunteer work anyway. I think replacing that, creating a better peer review structure could be extremely valuable, especially one that you can fund at scale. So if we suddenly get peer review done through preprints instead of through journals, I think that could be like a phenomenal outcome. I think there's probably some other things there around thinking about the scientific process and like the artifacts of science. So the objects that are made, how they're like found, and so on. There's some interesting combinations with AI that I'll suggest. So I think just staying abreast of all the latest LLM models and staying abreast of all the changes and being able to start coupling them to environments for scientists to experiment, meaning like training models on like all of the insights in a particular field to then use it as a thinking tool that can help you develop new ideas. So being able to like ask the thing to suggest more possible innovations or suggest types of experiments to try, or where you can have an LLM that is trained on like all the papers or something, to then like start probing it for interesting hypotheses or probing it for interesting experiments to try, where there might be a way of like tapping into like the rest of the scientific community through this kind of tool that is helping you think like the rest of the scientists. Now you have to worry about like tons of hallucination, so humans will have to like keep weeding out all the bad ideas, but I think that can greatly accelerate science. And I think maybe like so now kind of turning to inspiration wise, I highly recommend people try to get the broadest perspective they can. So one of the things that I found extremely valuable growing up again was kind of thinking about history and thinking about other like biology and astronomy, like knowing that the universe is so 14 billion years old or potentially more, is deeply world reframing. Knowing how we think life happened, and knowing how life is related, and knowing how cells work, and knowing how that entire system has developed is also massively worldview reframing. Understanding like different periods in history and how different communities and different cultures and civilizations try to do certain kinds of things is extremely eye-opening. Thinking through what were the bottlenecks of those times, trying to think through what was problematic in that area in that time. Why did like the Roman Republic never get to industrializing? Like that's an interesting question. Why did China, in its many possible dynasties of being able to like get to that scale, never did it? Why? What were the blockers? What were sort of like the kind of insights that led to the development of like the scientific revolution, or kind of like what were the social structures that had to change in order to get like broad publishing to happen, and the kind of appearance of like stronger peer review circles and so on. Like that's the kind of thing that if you study those kinds of developments in history, then you can zoom back into the world today and start looking at the world today with that kind of lens and think about some possible future set that operates very differently. And so it'll sort of thinking about peers in the past and understanding those problems will help you understand and see the problems today and see possible solutions that could be built. Now, before you go out and build and spend a lot of time building anything, think through the leverage points. Like what are the kinds of things that are smaller amounts of efforts that could translate to massive scale impact, and sort of prioritize your energy that way. Go for things that will have, much higher likelihood chance of success. You don't, simpler plans, simpler things that would then kind of translate into and ripple through lots of networks and lots of people to then cause massive scale impact. So that's, I don't know, the kind of stuff that I would throw out.
Yeah, awesome advice. And I'm curious, like maybe to end it off, if there's specific almost like resource, book or something in this direction that you would recommend, kind of like DeSci builders to read.
Yeah. So I'll rattle off a few, and maybe I'll start with like broadly inspirational ones, and then maybe get more. Actually, let's start with the more tactical ones, and then get broadly inspirational. So I think getting a good understanding of the history of various labs, I think is very valuable. So pick up the Idea Factories, the story of Bell Labs. Read that book, read that bibliography. Go look at all the Xerox Sparks ones, like Dealers of Lightning and How Xerox Fumbled the Future, or things like that. Go look into the books about like Intel and all the tech companies, all of Silicon Valley. You can pick up a bunch of books that talk about that kind of time period. Also, things like Turing's Cathedral. It's a great book because it tells the story of the beginning of computing. It tells the story of the building of the Joniac, which was like the computer in Princeton, built by von Neumann and a number of other people, and many other machines as well. So it gives you a feel for like the interconnected history of the beginning of computing. There's similar kinds of stories that are the kind of like the that are in the realm of like the MEMX or the DKR, which is like the Dynamic Knowledge Repository, which is Engelbart's work, to like all of the hypertext stuff that eventually led to the web and so on. Lots of really good ideas in there. And then kind of like more broadly inspiration, I would kind of like lean towards things like David Deutsch and The Beginning of Infinity, Fabric of Reality, phenomenal books. Check out his TED Talks as well. They're extremely, extremely valuable. And then, my personal favorite and probably most influential human is Carl Sagan. I think Cosmos was extremely formative for me, and his books and just his voice and his message, I think has been just tremendously, tremendously inspiring. And with that, I think like throw in a lot of interesting art as well. So, another favorite of mine is Melody Sheep, who actually got his start like by auto-tuning Carl Sagan and a number of other folks, and now makes extremely inspiring, phenomenal art.
Amazing. Thank you so much for this fascinating conversation and your insights. And excited to kind of like dive in even more deeply in future conversations.
Awesome. Thank you very much. I enjoyed this so much, and thanks for a phenomenal conversation.